10D, describe the end behavior of a function. So to describe the end behavior, you're just looking at the ends of the graphs. So if it's a quadratic, U-shaped, you're just looking at the left side of the graph, is it going up or down, and the right side of the graph is going up and down. If it's going up, we say they go to infinity, and if it was something like a cubic, I'd say the left side of the graph is going down to negative infinity, and the right side is going up to positive infinity. And so now we have to actually write that in a proper way. So you start that by saying, as x goes to negative infinity, so this is looking at as the x gets bigger and bigger negatives, what's happening in the graph. So you can also look at it as x goes to negative infinity this is the left side of the graph. So on the left side of the graph is the graph going up or down. So on the left side, the graph is going down. So it's going down here. So as x goes to negative infinity, the y values, f of x, goes to negative infinity in this case. And then, so that's the left side of the graph. So then on the right side of the graph, as x goes to positive infinity, so this is the right side of the graph, as it goes to positive infinity, so you're just looking at the ends of the graph, nothing in the middle. Don't look at the middle part of the graphs. In this case, it's just the ends. That's what end behavior is about. So at the right side of the graph, what's happening to it? It's going up to positive infinity. So looking at the next example, it's kind of a funky looking W. As x goes to negative infinity, you should be thinking left side of the graph, negative infinity. The x value is going to negative infinity. What's happening to the graph? And hopefully you're saying on the left side of the graph, it is going to positive infinity. That's over here. It's going up to positive infinity. And on the so as x goes to positive infinity, the y values go to, so as x goes to the positive infinity, that's the right side of the graph, right part. When I say left and right, I'm taking the y-axis and splitting the graph up into left and right. So f of x goes to positive infinity. So on the right side here, it's also going to positive infinity. With asymptotes, so now there's an asymptote. This is a log function. We have an asymptote here at -4. Asymptote here at x equals -4. So as x goes to, it can't go to negative infinity because there's an asymptote, so the graph stops. So it'll say as x goes to -4, what happens to the y value? So as x approaches, as it goes to -4, what's happening to the y's? And we see down here the y's are going to negative infinity. And on the right side, as x gets bigger and bigger and goes all the way to negative or to positive infinity, as you go to the right, what's happening? The y values are going where? And with log functions, it looks like it's almost flattening out for an asymptote, but log functions actually do not. They continue to rise forever and ever to positive infinity. So this is going to go to infinity. One more. So find the end behavior as x goes to negative infinity. As x goes to negative infinity, what's happening to the y values? In this case, I'll look on the left side, left part of the graph. What part is where the x's are going to go to negative infinity? That's here. What's happening? It's topping out at the y values are going to, the highest y value that's going to happen when you go to negative infinity is -2. As x goes to positive infinity, the y value goes to where? So as x gets bigger and bigger and bigger, follow the part of the graph that's going to happen where the x is going to get bigger and bigger and bigger. What's happening? They're also going to go to -2. Now there's things that happen in the middle here. You could say as x approaches -2 from the left, what's happening to the y values? So that would be, of course, to negative infinity. What's happening to the y values as x approaches -2 from the right? And that would be positive infinity, but we're not going to worry about writing it like that. Come to class with any questions. Thanks.